This is R. Devakumar from Hindustan Institute of Technology, Department of Mechanical Engineering. Yukti 2.0. We are presenting the project of Design of 3D Printer Hotend. We are the teammates Arun Prasad A, Kabil M, Siva Prasad N. We are guided by Mr. A. Jeevaratnam, Mr. J. Dixon Jim Joseph. 3D printer. 3D printer or the additive manufacturing is constructed of a three-dimensional object from CAD model or a digital 3D model. It can be done in variety of process in which material is deposited, joined or soldered under the computer control, which material been added together, typically layer by layer. In 1980s, the 3D printer were constructed suitable only for production of functional accessory prototype and other appreciating for its time was rapidly prototyping. As of 2019, the precision, readability, and the material range of 3D printing have increased to the point that some of 3D printing process and considered the variable and industrial production technology, whereby the form of additive manufacturing can be used synonymously with 3D printing. Advantages of 3D printing is ability to produce a very complex shape of geometry that would be otherwise impossible to construct by the hand, including the hollow parts or parts with internal truss structure to reduce a weight. Fused deposit modeling, which uses a continuous filament of thermoplastic material, is most common 3D printing process used in 2020s. 3D printing technology known as fused filament fabrication. A filament of plastic material is fed through the heated moving head that metals and execute it deposit it the layer after layer in the designed shape. For moving the platform, the lower from each layer is deposited. For the kind of technology, the additional vertical support structure were used, all needed to sustain overhanded parts. Hotend design theory. The hotend is arguably the most complex subset of 3D printers as it deals with the tricky business of melting and executing the plastic filament. To understand the design feathers, a hotend, you must have the basic knowledge of thermal properties of thermoplastic, especially the way they have behaved the glass transmitted temperature. The hotend and the coolant together to make up the 3D printer hotend block. The 3D printer heating block is a pot of extruder where the nozzle meets the thermal barrier tube. Contained within the heat block is also the heater cartridge and the thermocouple. Problem statement. The slow process for the 3D printing, the long waiting time for the print, the lacking of customized size. Abstract. The designing hot and black to change the flow to take the 90-degree turn. Changing the mount of the nozzle, reducing it the total height. Increasing the melting distance between the hot and the filament of the hot end by redesigning and the development. Cleaning the hot end block, changing the mount of a nozzle, increasing a melting zone, reducing the height of the hot. Solution. By introducing the upside down 3D printing, we have to achieve the low center of gravity. Fixing the center of mass in level, we can increasing a printer speed and the printing quality. By introducing a new hotend to upside down 3D printing, we can reduce the distance for heating element. Unlikely, the most 3D printers, the hotend and the XY gantry is mounted below the build plate directly onto the base. You must assume the printer needed to execute the plastic with the gravity to work properly. But in the real action is the smoothing of plastic layer. It appears that might even improve the bridging size. The hot end is supported to the plastic as it is get executed. This is also allow the user to still see the part and made the added advantage of beginning able to quickly the spot the bed leveling and aspirating problem. Another interesting side effect of arrangement is rigidity. There is a no need to suspend the XY guarantee with the heavy hot end in the air, so it can be mounted directly on the base plate. It is used a cross-tail guarantee with GT2 belt. To reduce the hot end height to fit the available space, the filament comes from the side and the mounted plastics make 90-degree turn before being executed. It took a few revisions to get the work right, but with a large volume of a melt zone allowed to increase a flow. However, we suspect it might also make a hot end maintenance slightly more difficult. There is a only corner we have to reduce the visibility of printed parts and the possibility of bit of plastic may drop into a gantry by the mechanism and jam it. Aluminium is without any doubt the widely used material for heat block. It may have a good thermal conductivity, low density, low cost, low maintenance cost. 6061 is a general purpose of alloy. It widely known under the T6 temper. The soldered temperature is 582 degrees Celsius, which is pretty low when considered of maximum operating temperature of 500 degrees Celsius. Though it is a first phase of hardening, the 6061 alloy is heated to 500 degrees Celsius during 9 to 10 hours to get a single phase of alloy. It means all added elements are dissolved in the aluminum. It is aged to 180 degrees Celsius for the same time of amount. There is a problem when considered using the material of heat block or printing temperature is within the aging range. There will be a slow bring of alloy back and at a base temperature, which reduce the tensile strength from 270 megapascal to 76 megapascal at the room temperature. Other aluminum alloys such as a high strength 2024 T4 or 7075 T6 have similar aging temperature, which bring the same design problem. The table below shown in the mechanical properties based on the temperature. The general purpose of aluminum to perform better than 2024 from 200 degrees Celsius and better than 7075 from 300 degrees Celsius. Mostly known as a nozzle material, the brass has some advantages compared to the aluminum. It has a very similar thermal conductivity and it is easy to machine. However, the price is little higher due to the high copper content. Brass should have significant advantages over the aluminum. The temper offered within the typical brass C360 brass are cold working and isn't affected by occurring the same way as aluminum. However, the new problem occurs and it called resination when brass is cold worked and the grains are stretched, squeezed and deconformed. This significantly increasing the mechanical property. However, the recrystallization starts happen between the 200 degrees Celsius and 300 degrees Celsius, which replace the forgotten grain with standard new one. The new grain have reduced the mechanical property. Key partners: 3D printer material suppliers, component manufacturers, distributors. Key activity: design and prototyping, manufacturing and assembly, marketing and sales. Value proportion: high quality and precision printing, fast and efficient printing process, customized and personalized option, lower material cost, reduce the production time. Key resources: skilled labor for the production, equipment for prototyping, manufacturing facilities and supply chain infrastructures. Customer segments: engineers and manufacturers, hobbyists, desktop 3D printers, print frames, channels, online stores, e-commerce platform, social media and exhibit event. Customer relationship: social media interaction, customer feedback and support. Cost structure: manufacturing and production cost, marketing and advertising cost, rent and utilization for the office and production facilities, research and developing cost, revenue streams, sales of hotend, upgradings of hotend.
This is our print country, which you can see in the given picture, this is in the prototype section. We are using two NEMA 17 motor to run the gantry, which is driven by the GT pulleys and GT2 belts. This is our first generation of heat plug. In this you can see we are using 24-volt heater cartridge and a glass bead thermistor. The glass bead thermistor is used to measure the temperature, and we are using 0.4 mm nozzle for the extrusion. And the heater block you can see, which is an bimetal heat block, which is manufactured by using aluminum and brass to achieve a 90-degree turn. Uh, and the golden side, which is taken from an E3D Seattle Horton. This is our second generation of heater block. In this, you can see we are able to achieve a flat bottom by using a flat bottom drill or by using an end mill, which is used to achieve a flat bottom, and by this we can easily manufacture the harden in a single piece. This is the Seattle harden which we are using as our base to manufacture the hotend assembly. In this, you can see the sectional view of the hotend, which clearly shows the component which are used in the hotend.
Thank you for one and all giving me an opportunity to present the design of 3D printer hot end project. Your thank you.